Alright, in this video we will be graphing some rational functions such as these. Depending on how long it takes, maybe I'll graph this one and this one all in the same video, or I might do 3 separate videos. We'll just have to see how the time goes. But let's definitely start with number 1. Alright, this is one of those ones that has a extra number on the end. So just understand that if there was no number on the end, in terms of the horizontal asymptote, the top degree here is 0 because there are no x's. The bottom degree is 1. We've learned that when the numerator degree is less than the denominator, that means that the horizontal asymptote is y equals 0. Alright, so that's a horizontal asymptote. So that would be the x-axis, would be an asymptote. However, I might as well erase this because putting a -3 on the end shifts everything down 3. So instead of being a horizontal asymptote at 0, I will have a horizontal asymptote at -3 instead. So the horizontal asymptote will actually be y equals -3. It's a vertical shift. Okay, so there is my horizontal asymptote. Now, vertical asymptote, we have learned that you can get a vertical asymptote by setting the denominator equal to 0. So if I do that, that's going to give me x equals -4. So x equals -4 is my vertical asymptote. Okay, after that, we need a bunch of points. I need at least a few points to the left of the vertical asymptote, and I need a few points to the right. Okay, notice, you should be able to tell me what the domain is right now, just based on the vertical asymptote. Okay, based on the vertical asymptote alone, the domain is going to be -infinity to the vertical asymptote, and then vertical asymptote to positive infinity, because the domain goes left to right. So without even drawing in the branches yet, I know the domain is going to be -infinity to -4, because that's where my vertical asymptote is. Alright, union -4 to positive infinity. Okay, it doesn't matter where the branches are, that's going to be the domain. So let's go ahead and draw the branches up. We need a table of values. Now listen to me well. Most of you try to stick to the integers and you avoid decimals. What I want you to do is, when you see a vertical asymptote, I want you to use values that are very close to the left and right. I want you to use decimals. So the vertical asymptote is -4. Whatever other values you use, to the left of -4, just a little bit to the left, is -4.5. So I want you to definitely use -4.5. Just to the right of the vertical asymptote is -3.5. So whatever else you use, I want you to definitely use -3.5. Okay, beyond that, you can use a couple other values to the left and a couple other values to the right. So, for example, we did -3.5. I could do -3. I'm sorry, that's not what I meant. We did -4.5. So continuing on the left, I could do -5 and -6. Okay, we did -3.5. I could do -3 and -2. Okay, so these are the minimum values I could get away with doing. Just for fun, I will also do, well, I'm trying to fill up my chart here, so I did -2. I'll also look at -1. Okay, so let's take a look and see what we have here. I'm going to use my TI-30XS multi-view. So let's see, my function is 2 over x plus 4. So I'll hit the table button. I'll hit 2 divided by x plus 4. And then I believe we had a -3 on the end. Now, for when I make a table of values, I like to use the ask mode, so I can use all the decimals I want. Now, I want to know -4.5. So I'll type that in. That's -7. I also want to know -3.5. So -3.5, just type that in. That's 1. Alright, -5. Type that in. Okay, so those first 3 values I wanted were -7, 1, and -5. Okay, now I want -6, -3, and -2. Okay, so that's -4, -1, -2. And finally, I want to see what's happening at -1. Okay, that's -7/3, which I can turn to a decimal to help me out. That's -2.3. Okay, so I'm going to graph all these points on this grid. Alright, so here's what it looks like when I've plotted my 7 points. Alright, so these points show me where the branches are going to go. So I can go ahead and draw my curve now as best I can. Alright, so it's going to approach the asymptotes on either end, but in the meantime it's going to go through these points. Okay, so your graph should look something very much like this right here. Okay, now the range. The range goes from bottom to top. So this is going to work similar to the way my domain was. But from bottom to top, it goes from -infinity to the asymptote. And then it picks up from the asymptote to +infinity. I'm going from -infinity to +infinity. In fact, the range is pretty much going to always begin and end. It's pretty much going to always begin with -infinity and end with +infinity. It's rarely going to be any different than that. Here's what I mean. So I'm going to begin with -infinity, and I'm going to end with +infinity because I'm going from bottom to top. Now in the middle, I'm going to make a pit stop at the horizontal asymptote. So I'm going to go -infinity. Now my horizontal asymptote is here. Okay, let me make this clear. So here's my horizontal asymptote, right? But this is at a height of -3. I'm right here at a y value of -3. So I'm going to go -infinity to -3. Union -3 to +infinity. Okay, bottom to asymptote, asymptote to the top. Okay, x-intercept. Well, when you want the x-intercept, what you do is you let y equal 0. Okay? Basically, you set the whole, this f of x is like y. So when I say let y equal 0, What I mean is you set the entire equation equal to 0. Alright, I'm going to put it on this side though, just because it makes me feel more comfortable. So if I set the whole thing equal to 0, this is how I find the x-intercept. So I'm going to solve for x right now. I can do that by adding 3 to both sides. Okay, so those cancel each other out. Make a little space here. So now I've got 2 over x plus 4 equals 3. An easy way to look at this is multiply by the denominator. So I'm going to multiply both sides of the equation by x plus 4. Alright, that way these are going to cancel out. That's going to leave me with 2 equals, alright, I'm going to do a little distributive property here. So that's 3x plus 12. I'm just solving for x. So subtract 12 from both sides. Alright, so that's going to give me negative 10 is equal to 3x. And last step is to divide both sides by 3. Okay, so there it is, negative 10 over 3. I've solved for x, so this is my x-intercept. Okay, just remember that negative 10 over 3. So x-intercept is an ordered pair, so I'm going to say negative 10 over 3, comma, 0. Do not give me a decimal here, leave it as a fraction. Now for the y-intercept, we let x equal 0. So you see the pattern here? If I want the x-intercept, I let y equal 0, which makes sense because the y should always be 0 for the x-intercept. And if I want the y-intercept, let x equal 0, which makes sense because the y-intercept is always 0 comma something. So the x value, of course, has to be 0. So if I let x be 0, that means I'm doing this. Let me just start all over. If I let x be 0, that means I'm putting 0 in right here where the x is. Okay, and this is f of x is like a y, so I'm just solving, I'm just simplifying. So that's going to give me y equals, now this is gone, so now I've got 2 over 4 minus 3. Okay, I'm just going to put this in my calculator. Yes, I know that's 1/2. Alright, so that's negative 5 over 2. Okay, so that gives me that the y-intercept is going to be 0 comma negative 5 over 2. Also, using the TI-30XS multi-view, if I want that y-intercept, I can go to 0 on the table. So table, okay, I can go to auto, or I can keep using ask mode, it doesn't really matter. But if I check out and see what a 0 say, 0 is negative 5 over 2, so that's another way you can get it. Now the end behavior, okay, end behavior always starts off the same way. As x approaches negative infinity, the function approaches, and as x approaches positive infinity, the function approaches. Now this first part means as we go to the left, the function approaches, and this means as we go to the right, the function approaches. Okay, so on the left, this is the left end of the graph right there. So as we go to the left, the function is approaching, okay, it's leveling out. It's leveling out at this horizontal asymptote. It is approaching negative 3. So on the left, it's approaching -3. What about on the right? Well, on the right, it's also leveling out. So this is the right. Okay, this is where you look for the right end behavior. And again, it is leveling out and approaching -3. Okay, the end behavior is always going to involve the horizontal asymptote when it exists. Alright, so that's not a coincidence that these came from the horizontal asymptote. Ha! Okay, that's all we needed for problem number 1.